Let I introduce Mr. Piyadit to everyone. Mr. Piyadit is a very well-known person in civil engineering communities. Currently, he is the CEO of the Civil Engineering Public Company Limited. He serves as the variety of the organizations, such as the VP of the Thai Contractors Association under Patronage of His Majesty the King. Right now, he's a board member of the Thai Commerce and the Social Committee in legal entities. He's also the alternate member of ABAC and the Eisenhower Fellow. So based on his bio, you know that today we're going to have very special speech for the opening ceremony of this session. So let's join me to give a very warm welcome to Kun Piyadit. Okay?
Thank you very much. Thanks a lot to Dr. Sukit for such a great introduction. So distinguished guests, ladies and gentlemen, so it's an honor to welcome you to the workshop toward digital construction for smart and innovative construction and infrastructure. So as a VP of the Thai Contractors Association under the patronage of His Majesty the King, I'm very proud to stand before such a distinguished group of professionals who are leading the future of highway engineering in Asia and beyond. So our theme this time is future-proofing roads for Asia and beyond, highlights the critical needs to ensure that our infrastructure is resilient, intelligent, and sustainable. Roads and highways are not just transportation routes, they are the lifeblood of our economies and the connection that drive our development. In Thailand, while we have begun to embrace digital construction technologies like BIM, IoT, or AI, our progress has been slow and still challenging. So we face significant hurdles, and there is an urgent need for a stronger push, especially from the government, to support this transformation. This success of the shift will require not just new tools, but a deep commitment to collaborate among stakeholders like government, contractors, engineers, and technologies providers. Together, we must drive this change to make our infrastructure projects safer, more efficient, and sustainable. This workshop is another testament to me to our collective commitment to overcoming these challenges and leading the transformation that can go further. So as we engage this discussion, let's keep our focus on the large goal, building infrastructures that not only meet today's need, but are also equipped to handle the uncertainties of tomorrow. By harnessing digital innovation and work together, we can ensure that the roads we build today will continue to support the progress for the generation to come. So I believe it's our duty to hand over a better world to the next generation. So I think today it's a great pleasure to come and see if there's anything or any opportunity that we can collaborate and move this forward. So thank you very much.
Very interesting opening speech from Kun Piyadit. You know that our community of engineering and infrastructures are able to protect our life and the people without the technologies. So in the trend of technologies around the world, I believe that in this section, our contractor, our government and consulting firm going to be collaborate to bring all the best of technology, cutting edge technology going to help us to develop very smart, innovative construction technology so that we can ensure the life of the people, particularly the people in Thailand. Okay, now read the first opening speech for today. We also have the second opening speech from our partner, Tata Steel. Let I invite Tata Steel partner to on the stage. Let I introduce Mr. Chalerm Bunyanubat. He's served as the VP for Marketing and Sales at Tata Steel Thailand. He worked as the Director Vice President and Prime Minister at Siam Iron Steel from 2012 to 2016. So the whole life of his experience, he just joined all the steel production and manufacturers. So it was interesting to launch the supplementary speech on the topic of sustainable steel material solutions service from steel manufacturing. So let's welcome Mr. Chai Serm for the speech.
Thank you, Dr. Sukit. So first of all, very good morning, good afternoon. So I think I'm very great to be here and to support support this program. This is, I think, is very important from the constructions. So since I'm come from the, let's say, the manufacturer that is try to to find the material, the raw material to support the constructions. We know that the construction will perform wrong for any more of the lies. So the material is the part of the very important. So today I prepare from actually Tata Steel is the part. May I explain a bit on my company? The Tata Steel Thailand is part of the Tata Steel. The Tata Steel is the global company that is allow more than 50 countries that is located from the Tata. And also the Tata Steel part of the Tata in the global. We have allowed 30 million tons to produce the steel. While the Tata Steel Thailand that's located in Thailand, we have the capacity is allowed 1.7 million tons per year that we produce the steel. And in the last many years, we also support the Department of Highway in the rebar, in the very high quality. That's in the subsequent slide we will explain you. And today I will talk about the sustainable. So we know that right now in the many let's say in many of the people or many the customer or the consumer, we are talking about the global warmings. The global warmings will start from the design, and also the material is very important. But in this I talking about the major products that is used in the construction. That means the construction rebar. So in the construction rebar, there are two process to produce. One we call that is they come from the blast furnace. That is use the iron ore as the raw materials. And the other process is come from the electric arc furnace. That is use the recycled material. That means use the scrap as the raw materials. But in the most of the the steel company that is produce the rebar is come from the blast furnace. Let's say around 70 to 75% is come from the blast furnace. But the point that is the blast furnace that use the iron ore and that generate the carbon emission is allowed 2.32 ton of the carbon from the ton of liquid steel. But why the electric arc furnace is when they produce the steel or rebar, it generates is the carbon emission is just only 0.6%. That is allowed almost three times less than the conventional the process. This is the one of the to reduce the let's say the carbon emission in our global our Earth. So if we compare in terms of the we know that the 3 times is reduced from the produce the rebar from the electric arc furnace that's used is scrap blade. But you can see that in terms of, if we use the 1 ton of electric arc furnace rebar, it will almost save the about 183 of the to reduce the carbon emission. Next slide, please. And of course, even the producer try to use the recycled material like scrap to reduce the CO2 emissions. One, the produce the rebar. But the more important thing that the producer or manufacturer have to continue to develop, to improve, to reduce the CO2 emission in the process itself. So there are around 3 processes that have to be used in terms of to reduce the CO2 emission. Once the manufacturer have to find the alternative material to looking from the whatever the raw material that can reduce the CO2 emission. The second, to improve the efficiency of the process. That means to reduce the energy consumptions or fuel consumption. The last is not the least, to find the let's say alternative source or alternative energy, like the solar cell or maybe come from other. This is the 3 items. So with the 3 items, this it will generate like what we call the circular economy. And in terms of circular economy, it comes from the carbon footprint product. This is the one that is important. And if you know that right now actually in the European country, they concerned about the CO concern much on the CO2. Right now they implement the CBAM. So one of the to certify the material, yes, we should have the EPD. EPD means environment product declaration. So with the EF or rebar from electric arc furnace, that will get the CO2 emission is less. Then the EPD will certify this product. Next, please. And a part of the raw material that the electric arc furnace use, we also thinking from the how to reduce the number of the steels. So whatever is the manufacturer can design, can regulate or improve the material or the quality of the product. Instead of use the plain steel that can use in the high tensile. That means it can reduce the quantity of the steel. For example, if we use the high tensile to the construction, what we call now is SD50, that it can reduce up to 20%. 20% means it's almost, let's say, around 14 tons. So if we use the conventional steel, it will higher than SD50, around 14 tons. This is for example. Next, please. A part of the materials, so manufacturer try to reduce the time, because the time is very important in terms of the construction and also in terms of the waste. So the manufacturer also try to develop or try to introduce the cut and bend from the plant. That means it can reduce in terms of the waste and time, and also even the quality will be every shape will be as per the standard. Next, please. So this is the overall of the what I would like to tell today. So the one important thing that is the manufacturer will try to improve or to find to support the construction in order to do the sustainability. One is search for the electric arc furnace rebar. That is can reduce the 1/3 of the carbon CO2 emission. The other is use the high tensile or use the cut and bend. This will improve the sustainability from our earth. Thank you very much. Thank you.
Okay, thank you so much for a very interesting topic that if we integrate the manufacturers to be the greener process, particularly to use the reduction of the CO2 footprint from the industry, it's going to ensure that the Department of Highway going to produce and develop the highway construction project that use not only the digital construction but also use the friendly material construction as well. That is going to be leading our society to the resilient and sustainable infrastructure development. Okay, for the second opening speech, it ends like this. So the next session is going to be very interesting as well. Our session have the 4 experts that are going to join our session that come from the digital construction industry and also some kind of the environmental and infrastructure monitoring technologies. So let I introduce the first speaker onto the stage, to the seat here, Mr. Eddie Hong from Midas IT, South Korea. Okay, for the first topics, it's going to be about BIM and digital technology for design. And today we very pleased to have our speaker to be very expert in the BIM and digital software, Mr. Eddie Hong. So let's join me, give a very warm welcome to Eddie Hong for the presentation on the Midas SIM for engineers, utilization of SIM.
Hello everyone, my name is Eddie Hong, and I am from Korea. The Midas company, HQ is based on Korea, Seoul. So very glad to meet you today, and thank you for joining our session. So I will introduce of Midas software, especially for the BIM sector. Midas CIM is already launched last year, so very brand new software for the BIM sector. So let's talk about the Midas CIM for civil engineers. So today's contents like this. First, let me give you a quick overview of what is the Midas CIM software. If I have to describe Midas CIM in one line word, the linear-based 3D modeling tool for the civil engineering. In fact, CIM developed by Midas is a 3D modeling tool and for the civil engineers, especially structural engineers. And CIM can be used throughout the entire engineering process. So as you will see in the presentation, it is easy to utilize even for existing civil engineers by providing various libraries and templates integrated with our other software to produce high quality of results. I used the term of a civil specific earlier. Why did I say that? The typical architecture modeling tools support layer and grid-based modeling. For the real work, it is difficult to present a 3D model of civil structures such as bridges, roads, and tunnels, something like that. However, CIM is a modeling tool based on linear and segments. So civil structure engineers are laid out along linear lines, as shown in the image. This video is for about 3 minutes for the Midas CIM concept video. In our experience, when we work on civil engineering projects, we usually plan a linear line and build a bridge when crossing the sea or river. In the case of CIM, the model is completed by assigning the model to the location where the bridge is on the linear line. The model is also linked to the changed alignment and reducing the modification time for all engineers. If we change the layout line, and we will upgrade directly in the modeling. And also we can check the value of interval or update automatically the model. And also our CIM program represent the detailed river arrangements, even including the tendons and split joint and couple assigned. Lastly, we can check and generate the 2D drawings from 3D modeling. And we align the 2D and 3D model. So if we change in the 2D drawings some parameters, we can upgrade directly to the 3D model. And finally, we export to the civil software. By the civil software, we can analyze the FM model. So how can we do that? Well, to achieve this CIM has unique model space and logic. So I would like to introduce the core of CIM process. In this case, space is a library mode of points, and the curve library mode that's going to be located at different places on the line, and assembly mode to assemble these libraries, and finally there is based model mode that assigns the assembly libraries to the linear to create the final model. So we can make a model, these all components, like size, even piers, barriers. And lastly, if we make a model, the libraries, and then assign the layout, and finalize the 3D model. So let's go ahead and show you how to actual model the bridge in CIM. So I would like to introduce the smart template and catalogs. We already have some libraries in the software. So we can check some libraries and modify the pre-stressed concrete bridge and layout check, and then a modification in the smart template library, gutter ranks or other components. And lastly, we can check the other components. And then sorry. Okay. Besides the PS beam bridges, there are many other templates in CIM, like tunnel and other method of bridge, FCM, FSM. And we even offer special bridges like cable stage and suspension bridges. And so you may not use it often, but it can be useful if you need to compare bridge types in the planning stage. And as I mentioned earlier, there are about 200 libraries built into the catalog, our catalog. So you can just download and use them if you need to. You can modify and adapt them. In fact, you will be more efficient in your work by modification and adapting provided libraries rather than you creating them from scratch. So far, you are getting the idea of modeling. How can we utilize this software? So let's take a look into how you can utilize the model you have created. In CIM, you can actually do a lot of different things with the model that you create. The first is compatibility with another software like analysis tools, and you may be most interested in. Structural engineers will eventually need to create an analysis model. So this is the modeling time varies depending on the complex of the structure. As you can see, we are not just sending element geometry information. You can use these functions. You can create an analytical model with self-weight and boundary conditions in minutes. And in the real project, the CIM, you can define the boundary conditions of rigid link, elastic link, support, and model exists for model updates. 1D frame elements and 2D plate elements can be linked. Let's take a look at how we can use these features to export a 3D model. We can just create the analytical model using these features. If we change the girder with a composite section to create the grade model. After defining the case conditions to create the analysis model in this mode, and click export, and the analysis model will be created in our Midas civil software. And finally, you can see that the boundary conditions and section informations that we applied earlier in the CIM model. It is only this bridge possible? No, it doesn't special bridge with tendons like this can also be interact. So, of course, additional loads and load combinations are required. So, but the modeling works very well. When designing a structure with complex forces, we have 3D analysis model may be required by client. So if you need a plate model, such as the structure in the video, you can easily link to 2D plate elements using the slab elements pictures. So you can see how well it works. And this part, as you can see, the parasolid type object provided in the CIM model is export to FANX software to perform FAM analysis. Models are created in other 3D tools like Revit software or other 3D BIM software can also be imported in this way to create an analytical model. So in this video, a parasolid model created in another software is imported into the CIM and then create the analysis model using the analysis line function. So I think that's something that everybody in Loom today has different needs depending on the role and size of company and the strategy of your company. Some of you are engineers, so it is drawing capabilities. So it depends on your industry, but drawings are always required as a design. In short, in CIM, you can extract drawings by using the drawing functions in CIM. So you can create a section drawing of any section and rebar drawing with bar width. And as you can see, you can extract the geometry and draw it simply exporting dimension lines. And also, when using the existing civil for general sections that are not provided as a DB sections, so you have to create sections through the SPC function. So some people may have difficulty using it. So now you can do this Midas CAD software design as well. There's a lot of more functions in CIM. In the following, I will introduce the other various features the CIM. First, this is a feature that allows you to add detail to your model. It automatically generates boards and stiffeners that will be used a lot of steel bridges. And it also provides the tendon generation function required for PSC opening bridges. And it's possible to create distribution diagram. Rebar input function is provided this. This is a description of the parametric model. For example, the geometry model may change due to changes the plan. In this case, the model modification is required. So you can easily change the shape through variable processing, as shown in the video. Even if the rebar is model and rebar information is linked, just adjusting the variable of shape. Finally, there are a number of CIM competitively that are import and export functions with CIM. So you can import and export to IFC, Parasolid, and CAD objects, etc. It will be needed. So let's take a quick look at how they are compatibility. You can import a model created in Revit software into CIM and linked with the civil analysis model. This is possible by utilizing the analysis function. You can also opposite process export model from CIM to other software, and 3D object model create in CIM with a library, some information. If necessary, they can convert into IFC or other format. And finally, let's take a look at some examples of what we have been able to do with these CIM software in the real project. In Korea, where Midas is a headquarters, many structures are modeled using CIM. It is used to design general bridges, including pedestrian bridges, subway stations, and overall civil engineering structures, such as utilize cable stage up bridges and temporary facility. Here's a video of one of them. The role of structural engineers is somewhat different each country. In Korea, structural engineers do structural analysis and drawing together. So, in particular, we work on complex distribution such as settlement halls in advance to see if there are any construction problems, clash checks, such as. And right now, the most active users of CIM are in China and India. So it's being utilized by civil engineers for a real wide variety of bridge projects. The Dongjing bridge you see on the screen is 2 tower cable stage bridges. For concrete cable stage bridge, PSS box girders are usually applied. We want to know easily the model attendance on PSS girder, so we used CIM, which provide a tendon generation function. The second Sangjia bridge is a high and low pagoda river bridge. As you can see, the bridge is located on the curved line, so it's not easy to make a model with geometry. And this is a case where we utilize a CIM to take advantages of ability to link object to linear. The The last one is another video. As you can see, this is very complex arc bridge. It was a project that required a high level of detail. So we used CIM, which has a lot of modeling freedom. So this is how the rendering where we create in the CIM software. Now let's wrap up things. So we have been talking about how Midas CIM software can be utilized by civil engineers. Midas, we think of it. What is the easy way to make for the civil engineers a little more efficient way. So CIM will definitely save modeling time, and it is not difficult if you try it. Some Korea and China engineers, they are using it, mostly intermediate level of above level in about within 2 days. So you can you can utilize any project with a CIM. So honestly, if you only learn the functions required for your task, 1 day is enough, I think. So finally, Midas always actively supports the growth of civil users who participate today. So thank you for joining our session again and listening my session. Thank you.
Okay, let I summarize in Thai. Okay, ก็ท็อปิกแรกนะฮะก็น่าสนใจมากก็เป็นการนำ Digital Construction ที่เกี่ยวข้องกับทั้งการออกแบบแล้วก็การก่อสร้างนะฮะโดยใช้ตัวซอฟต์แวร์ของ Midas นะฮะโดยหลักการก็คือว่าปกติเวลาเราอยู่ในอุตสาหกรรมก่อสร้างอาคารเนี่ยเราก็จะเรียกตัว BIM ก็คือ Building Information Modeling แต่พอเป็นที่เกาหลีเนี่ยถ้าเป็น infrastructure ทั้งหมดเนี่ยเขาจะตั้งชื่อว่าเป็น SIM นะฮะก็คือตามเป้าประสงค์ของตัวรูปแบบของงานก่อสร้างเลยโดยหลักการคือว่าสมมติเราพยายามที่จะพัฒนา infrastructure โดยใช้ Digital Construction ต่างๆเนี่ยขั้นออกแบบเนี่ยถือว่าเป็นต้นน้ำดังนั้นตัวที่เขานำเสนอเนี่ยจะสังเกตว่าเราสามารถเอาตัว Digital Information ต่างๆตั้งแต่เรื่องของterrain ตัวภูมิศาสตร์ต่างๆมาเป็นดิจิทัลเสร็จแล้วในการออกแบบเนี่ยเราสามารถที่จะใช้ตัว alignment ของถนนหรือแม้แต่สะพานเนี่ยสามารถที่จะลากเข้าไปในตัวค่าระดับต่างๆได้เลยแล้วสุดท้ายสิ่งที่น่าสนใจที่สุดก็คือว่าเราสามารถที่จะสร้างตัวแบบจำลองของสะพานที่พร้อมการวิเคราะห์และออกแบบได้ในทันทีเลยแม้กระทั่งงานออกแบบถนนเขาจะมีการปรับเปลี่ยน alignment ยังไงก็ตามเนี่ยทางตัวซิมของ Midas เนี่ยสามารถที่จะ handle ได้และสุดท้ายเนี่ยเพื่อตอบโจทย์อุตสาหกรรมก่อสร้างในหลายๆประเทศเนี่ยซึ่งเวลาเราจะทำ TOR หรือทำ tender ต่างๆเนี่ยยังไงต้องมีแบบ 2D เพราะฉะนั้นเขาสามารถที่จะgenerate เป็น 3D drawing ได้ก็จะทำให้เราสามารถที่จะตอบโจทย์การออกแบบที่เป็น digital construction แล้วก็ procurement process ในหลายประเทศได้นะครับอันนี้ก็ถือว่าเป็น point of view ที่น่าสนใจมากนะครับเพื่อให้แต่ละเซสชันเนี่ยสมูทนะครับผมอนุญาตให้ในแต่ละท้ายเซสชันเนี่ยถ้าท่านมีคำถามจากที่ฟลอร์ข้างล่างเนี่ยสามารถที่จะสอบถามสปีกเกอร์ได้นะครับซับ 1-2 คำถามสามารถถามเป็นภาษาไทยได้แล้วผมจะแปลเป็นภาษาอังกฤษให้นะครับOkay, probably I'm going to be the first question for you. It's very interesting to have the software Midas here in the presentation. Basically, in Thailand, we're going to have very large-scale projects of the bridges, like the suspension bridges. So could you just explain, is it possible to integrate that, this software to suspension bridge design? And how? Something like that.
You mean integrate other software?
Yeah, and also use this in terms of the design process for the largest long span bridges, like the suspensions.
Yeah, of course, CIM can be useful for this suspension bridge and cable stayed bridge. So I recommend we already implement some catalogs and libraries from starting from these libraries and make a model and modification some parameters and other linear layout so that we can easily make a model, full model, or including components. And then if we some engineers need to export other software like Revit, Structure, or Tekla, or Allplan, all these software we can export or import this software, and then finalize the make a full analytical model. So if you finish the analytical model, we can export from CIM to Midas civil software. So fully export these components. So.
ก็สรุปว่าสามารถใช้ Midas Civil ในการออกแบบสะพานต่างๆได้เลยโดยสามารถใช้ library ที่มีอยู่แล้วหรือการสร้าง library ขึ้นมาใหม่นะครับแล้วก็ยังสามารถที่จะ integrate กับซอฟต์แวร์อื่นๆจากค่ายอื่นๆได้เช่น Revit Allplan หลายๆโปรแกรมเลยซึ่งถือว่าก็เป็นซอฟต์แวร์ที่มีความเป็น powerful tool อันหนึ่งสำหรับ digital construction and design อย่างสูงนะครับก็น่าจะมีคำถามข้างล่างโอเคเชิญคุณชายครับโอเคเอาขออนุญาตขอไมค์ให้ทางคุณเบียร์ดิตครับ
Thanks a lot for Eddie for sharing. So my question is, I just wanted if you could share the process, because I'm sure that SIM is not just for design or construction, but it also have the capacity of the information and how to do the construction, and also for the whole life cycle of the facilities, so for the operate and maintenance as well. So just wondering if you can give example in Korea. Currently, what is being handled by the government agencies, starting from design and then goes to contractors and then it hand over to the operator. So how SIM has been involved in the process and how it's working, because I think to me to see if there's a collaboration between the government agencies, construction companies, and also those who's going to do the operate and maintenance and use this as a centerpiece and then roll this out for the whole thing. I think it's going to be great. So just want to hear some sample and practicality now in Korea. Thank you.
Yeah, actually the CIM software can use government agency and construction company also, they can use this software. But I recommend always, at this current state, our current state of CIM, we recommend for civil structure engineers only for this field. But we have also have many capability of construction site. For example, we can generate the BOQ quantities and extract the 2D drawings for the construction level of LOD 300 or 400 we can cover. So we can generate the detailed 2D drawings. And but I think other softwares like BIM software, Revit or Tekola is also capability more deeply capabilities these level of functions. So, but our CIM software a very strong point between with interact with our civil software for the analysis and design process, and that's why I recommend the civil structural engineers. Almost civil engineers, companies or government agency divide into two departments, CIM department and structure designers. So if someone use the CIM software, maybe structure engineers or BI modeler use this software, we can cover together for the analysis and BI sector. So is it sufficient reply? Yeah. Thank you.
Okay, thank you so much. ก็คำถามของคุณปีดิก็คือว่าเราสามารถที่จะนำศักยภาพของซิมใน Midas เนี่ยไป explore ต่อทั้ง life cycle ของ infrastructure ได้ไหมเพราะว่าตัว life cycle ของ infrastructure เนี่ยมันก็เริ่มตั้งแต่การออกแบบก่อสร้างเสร็จแล้วทางภาครัฐเองก็ต้องบริหารจัดการ maintenance แล้วก็ operation เพราะฉะนั้นคำถามก็คือว่าเราสามารถเอาตัว tool ตัวนี้ไปใช้ได้หรือไม่ซึ่งทางตัวแทน Midas ก็บอกว่ามันได้บางส่วนได้ส่วนหนึ่งซึ่งแน่นอนว่าอาจจะต้องมีการ integrate กับซอฟต์แวร์อื่นๆด้วยนะฮะเพื่อให้สามารถที่จะตอบโจทย์ทั้งเรื่องของoperation and maintenance แต่อย่างไรก็ตามตัวของเขาเองเนี่ยเขาสามารถที่จะช่วย support ในเรื่องของข้อมูลด้าน BOQ ซึ่งก็คือไปถึง state ของ construction นะครับซึ่งจริงอันนี้ก็เป็นมุมมองที่น่าสนใจเพราะว่าในเชิงภาครัฐเราเองเนี่ยหลังจากที่เรา bidding เราสร้างเสร็จแล้วเนี่ยยังไงตัว infrastructure เนี่ยอยู่กับเราไม่ต่ำกว่า70 ถึง 100 ปีนะฮะเพราะฉะนั้นoperation and maintenance เนี่ยก็ยังสำคัญซึ่งอันนี้เดี๋ยวภาครัฐเองก็คงต้องรับไปดูperspective แล้วก็ tool ใหม่ๆเพื่อเราสามารถที่จะไปถึงresilient structure แล้วก็ sustainable ได้ตามที่เราตั้งเป้านะครับ Okay, thank you so much for the first speaker. It's very interesting to have you in our session. So the next speaker is going to be a very interesting topic as well. We have Dr. Francesca from Entrust company from Italy. She's going to deliver the topic of smart infrastructure, IoT, and also sensor integration in the BIM. They're going to be integrated for our operation and maintenance perspective as well. So let's give the very warm welcome to Dr. Francesca again.
Thank you very much, everyone. Thank you for your great introduction. So yes, I'm Francesca Briganti. I'm the SHM specialist and the international sales director of the company M+, but also a researcher in the University of Trento. So what I would like to do today is to use Italy as the main case study. Italy is in fact a national-wide case study for structural health monitoring. I will present not only the Italian panorama, but also Italy's best practice, and then I'll conclude with some real-life case studies. As we all know, Western world infrastructure are aged and overstressed due to increase in traffic loads, but also natural calamities like landslides and earthquakes. So as risk factors are increasing, bridges are collapsing. Some of you may remember the tragic collapse of the Morandi Bridge in 2018, where 43 people unfortunately passed away. This was actually the 11th bridge collapse since 2013, so in just 5 years we had 11th bridge collapse. But I want to point out that Italy is not actually the country with the most collapses. United States is. But the thing is that structures are surpassing their desired service life, so this is inevitable everywhere. This might have been a Western world problem in the last decade, but it will become a worldwide one very soon. However, the Morandi Bridge was the very first that hit very hard the largest Italian highway operator. And this created a very big public pressure of people asking for a smarter way to manage infrastructure. So this led to the deployment of structural health monitoring, because this new technology allowed to do two main things: maintain only when needed and where needed, and maintain efficiently. But this is not the only advantage. Actually, SHM allows for effective cost decision making. In fact, SHM allows for a holistic overview not only of the single structure, but of the entire stock. So it is possible to have a total control over the national infrastructure. This allows for the decision of the optimal mix of intervention and for planning accuracy, which improves risk management and processes, and also improves iCHE score, which is environmental, social, and global scores. So actually, structural health monitoring came as the crossing point of some key macro trends, among which, of course, there was the aging of infrastructures, but then the deployment of IoT technology, the big data analytics and artificial intelligence development, the digital twins and certified data that allowed for the implementation of blockchains and smart contracts. All of these leading to a great rating tools for managing assets and for improving ESG scores as well. So what did Italy do in this context? Italy realized that investment in SHM were inevitable, and therefore they inserted SHM into a very big process that was not only the deployment of the technology, but involved many sections like the inspection of bridges and bridge management system implementation, structural health assessment, the actual deployment of the technology, of course, but then also the digitalization of the infrastructure that allowed for transitability grade assessment, risk rating, and periodic reports on the state of infrastructure. Since the phase of inspection is concluded in all the Italian nation, we are now passing on the phase of the deployment of the technology. So in Italy, there is right now a very large, the largest actually, investment plan rollout so far. This includes 1.6 billion of euros investment into the deployment of this technology. ANAS, which is the largest highway operator, tendered 280 million euros for the deployment of this kind of technology, plus 160 million of self-fundings. And other highway operator followed at fast speed. 450 million of euros of this 1.6 billion investment is entailed for the program with three main objectives. The inventory and classification of the structures for the risk assessment, the monitoring system equipment for 6,500 structures all over the nation, and the BIM modeling of 200 structures. However, how did Italy choose which structure to monitor? Because as we all know, the budget doesn't allow for the implementation in the entire nation. And Italy was the very first to realize that it wasn't feasible to conduct thorough assessment of all the infrastructures. And so, for the first time ever, they created some guidelines with low inputs, very easy through flowchart that allowed for the classification of all the structures in the nation. This classification was based on the main risk associated with civil infrastructures, which are the structural risk, of course, the seismic one, landslide, and hydraulic risk. The combination of the risk associated to this parameter led to a global risk, and all the infrastructure ended up in medium, high, and high classes were compelled to install structural health monitoring systems. So why am I talking about Italy so much, apart from the fact that I come from there, is because that Italy created for the first time ever a national-wide case study on iCHE, where iCHE was applied to real structures and provided the advantages for the whole nation. In fact, what we saw in Italy was that we had very big problems connected to the aging of infrastructures, the lack of documentation to do assessments, and the climate changes increasing catastrophes. But thanks to the implementation of the whole iCHE process, so the inspection, BIM and FEM modeling, the bridge management system implementation, and deployment of the technology, Italy was actually able to reduce risk and liability connecting to management and the ownership of infrastructures, to optimize the capital expenditure of all the companies connected to infrastructure, with a very big reduction in service interruptions. This created a very fast decision tool for rating the assets, which led at the end also a reduction into insurance costs. So actually the Italian code inserted a new definition of health monitoring of infrastructure. This was not only sensor-based anymore, but it was a whole process which entailed the inspection of the bridges, the bridge management system and BIM implementation with finite element models calibration, the deployment of the technology, but also of the software to manage the data coming from the technology, and the engineering services connected to the analysis of these data. So for the first time ever, iCHE was defined as the combination of three main parameters: the hardware, the software, and the engineering services. The guideline for structural health monitoring, in fact, states that there are two ways of monitoring the health of infrastructure. One is the most common one, which is visual inspection and non-destructive testing, that it's done worldwide. But the second one is the active or IoT monitoring, which is composed by a permanent measuring system and from a data acquisition system. The following circular defined also that in order to manage data, there were two main ways. One was the data-driven method, so basically statistical trends are used to set thresholds on the data coming from the infrastructures. The second one is the model-driven methods, where we compare the FEM calibrated models, the original models of the structure, with the data coming from the field to detect any abnormal behavior of our infrastructure. I would like to present some case study to make you better understand what information structural health monitoring can give to real-life infrastructures. First of all, let me roll out how usually our iCHE project is done. First of all, it is necessary to inspect the infrastructure, single structure or many, the one we want to install our technology in. Then comes the risk assessment of this structure with the identification of critical elements or structure in the whole stock. What would be best would be conducted dynamic tests to create a simplified FEM model to compare with the data coming from the field. This would allow to identify any criticality on the structure so that we can choose the best design of monitoring system to install on the structure. Then, of course, it follows the installation of the technology, and then the actual monitoring, which in case we don't have FEM modeling, could be 1 year to set the baseline of behavior to compare with the following data. For all the following case studies, the system Vittorio, the proprietary system of N+, was employed. This is a unique system because it is particularly designed for massive installations. Its particularity is that it works in series, so we don't have each and every sensor connected to data acquisition system. But actually there is series of sensors which allow for very long installation without the loss of quality in the data transmitted. This system is also designed to be open to third-party sensor, so that if there are any parameter that we want to acquire or the client wants to acquire that M+ doesn't produce, it is possible to integrate those third-party sensors into our system. And the system is also designed to be plug and play, so easy to install, and durable because it is designed with military components. The reason why this case study were conducted with a wire and non-wireless system is because a wire system allows for many more kind of monitoring, especially when we're talking about permanent and very high frequency monitoring, which might be the dynamic monitoring. The actual first case study I would like to present is Montevideo Viaduct. This is a viaduct located in Trento, the city where my university is. And the problem connected with this infrastructure, which is a steel structure, simply supported, was that, is this a pointer? Yes. Is that the hill that you see behind the structure was having a landslide. So the owner was actually worried that the pier that you see right here was affected by this landslide. So what we did here was designing a monitoring system to monitor that single pillar. In particular, we use accelerometer to detect the modal shapes of the two spans next to that pier. We use this configuration because it's the best one to detect both the longitudinal and transversal mode. Then we put inclinometers on the spans next to the pier. You can see, okay. Because of course, if the pier is sinking due to the landslide, then the two spans next to it are rotating. Finally, what we realized was also that if those two spans are actually rotating, then probably the joint in between them was stuck. And so what we did was to install also some displacement sensors, potentiometer sensors, here on the joint. The first data that we went into analyzing were the vibrational data, so coming from accelerometer. This allowed us to detect the modal shapes. We had the first three modes, 1, 2, 3, but then we noticed these three peaks on the first mode. These in data analytics can have two meanings. One is noise, which might be because that was a high-speed road, so with trucks passing on, so it could be a little bit of noise. But there is another explanation, which is that this is the behavior of continuous span, which have the first three modes overlapped. So now we needed to verify whether this was the case or not, because this was a simply supported bridge. And if it was behaving like a continuous span, then maybe the joint was actually stuck, as we believed. So we went immediately into the joint displacement measurements. We saw this behavior, but we weren't worried about it because we know that Italy has very high temperature variation. And in fact, as soon as we compare with the temperature trend, we immediately saw a correlation. It is very clear at bare eye, but we also went into an algorithm to thermal compensate the data, basically, so to clean the data from the temperature effect. And this was what we obtained. So we obtained that the joint behavior was perfectly fine, perfectly within the thresholds. So the joint was actually behaving pretty well. So now we had two different situations. One sensor said, I might be affected from noise, but I might also indicate a problem. And another sensor, the displacement sensor, saying everything is fine. So we needed a third opinion to confirm one of the two. So we went into the rotation data, the one coming from the inclinometers. We were very happy with the data at first up until the 29th of October, where there was a sudden rotation of the structure. This seems really big, but we are talking millidegree, so these sensors are actually very sensitive. But we did see this sudden rotation of the spans. So we contacted immediately the client, also the alarms of the system went off, but they told us that on that very day, they had installed a very heavy working site on the bridge to redo the pavement of the bridge. So the fact that the bridge rotated a little was due to the heavy weight of the working site. So we resetted all the thresholds, continued the monitoring, up until the working site was removed. And what we saw was that the structure went back to the original rotation. Not quite the original, because as you can see from the light gray data, that was due to the extra weight that was added with the renewal of the pavement. But that meant that the ground underneath the pier was still supporting the bridge, and the bridge was able to go back with its original configuration. This was a very good news for the owner, of course, which was actually able to put the capital expenditure of that year into another structure that needed an intervention the most. The second case study is the Duomo Cathedral, so the Cathedral of Milan. The situation here is pretty similar in some ways. I mean, of course, this is an historical structure, and the problem here is that the square that you see underneath the Duomo is slowly sinking, so the case is pretty similar. The problem here is also that we do not have the original design plans of this cathedral, so we don't know how the foundations are actually made in this particular building. So what we decided to do here was a static monitoring system where we put inclinometers on the main columns so we could see the rotation of the column due to the sinking of the ground underneath, but also string gauges, because we realized that if the displacement underneath the Duomo was differential, then probably the horizontal elements were undergoing an abnormal stress on them. So, for now, the Duomo is perfectly fine, but this case study has two main meanings. One is, of course, the safety of the users, because thousands of tourists enter this building every day, so as soon as there will be something off with the structure, alerts would go off and the structure will be evacuated. But especially, what we are doing here is that we are giving the data coming from the sensors to the Polytechnic of Milan, which is using the data to reconstruct a beam model of the cathedral and do some simulation to understand how the actual foundations are. Another case study is Casal Maggiore Bridge. This is one of our first installation and also the longest SHM project in Italy. You're seeing just a very small portion of the bridge. You're seeing 4 span, but this is actually a 34 span bridge, 1.2 kilometer long. The problem in this bridge was caused by the old age of the bridge, and especially by the fact that the loads on the bridge are increasing very fast. The owner of the bridge actually put a load limitation on the bridge, but the fact is that he knows it is not being respected. So what was done here was the installation of a weighting motion system to detect the actual weight of the truck passing on the bridge, and then some inclinometers to correlate the deformation of each span to the loads passing on the bridge. Here we had 2 outputs in this case study. First of all, the weighting motion system was connected to camera to photograph the license plate of the trucks, the overweight trucks, and some alerts were sent to the police, and the viral message passing among the drivers which were receiving fines decreased the overweight traffic load of over 40%. But also, we were able to detect, thanks to the correlation of the weight to the rotation of the spans, we were able to see that just 2 of the 34 spans were having an abnormal behavior. So once again, the owner was able to allocate the budget on those 2 particular spans instead of renovating the whole bridge, which would have had enormous cost. This is the Toano viaduct, and here the case was really similar, because once again it was aging and the traffic was increasing very much on this viaduct. But the reason why I'm presenting this is because here the owner didn't want to stop the overweight traffic, but they wanted to create a BIM model of the structure, a digital twin of the structure. So here we use dynamic data, because dynamic data are the ones that give out the most information about the bridge. And so thanks to the system installed, the owner was able to reconstruct a model. Anyways, for this bridge, a full restoration is due. So this was a sole purpose of do some simulation for until the restoration was done. My last case study is the Dolo Viaduct, and I present this case study because this is a fairly new structure for Italy, with no problem of aging, no problem of degradation, nothing at all. It was perfectly fine. But the thing is that this structure was constructed prior the seismic codes in Italy. So they needed to compel to the seismic code and adapt the structure to those requirements. What they did here was very smart, because this highway operator manages many similar structures. So there are I think nearly 20 or 30 structures which are just as this one. So what they did was to install a monitoring system before the renovation, and then they decided to renovate each element of the bridge with different techniques. So by monitoring the status of the structure before and after the renovation, they were able to tell which one was the most effective against seismic effects, and that one was used to renovate all the other bridges of the stock. So this concludes my presentation. I hope this was interesting to you and informative. And if you do have any question, you can ask right now, or of course, contact me anytime at this contact info. Thank you.
Okay, let's summarize this topic. It's very interesting for the sharing of the information for this session. สำหรับ second topic นะฮะที่ทางดร. ฟรานเชสกาเนี่ยได้นำเสนอกับพวกเรานะฮะก็จะเห็นว่ามีความน่าสนใจอย่างยิ่งเลยเพราะว่าในท็อปิกแรกที่เราพูดถึง BIM หรือ SIM แล้วเนี่ยที่เป็น fully digital modeling ใช่ไหมฮะแต่เวลามาทำในเชิงที่เป็น operation and maintenance เนี่ยภาครัฐเองเนี่ยเรามีความจำเป็นที่จะต้องนำ digital information เหล่านั้นเนี่ยมาทำอย่างไรถึงจะบริหารจัดการข้อมูลหรือสภาพการเปลี่ยนแปลงของตัวพวก infrastructure หรือสะพานได้โดยเป้าหมายหลักๆเราก็คือเราต้องการที่จะทราบความเสี่ยงบริหารความเสี่ยงของ infrastructure ระหว่างที่ operate ได้สะพานเวลาเปิดใช้งานไปแล้วมีรถวิ่งแต่ละวันเป็นแสนคันมีการเปลี่ยนแปลงสภาพภูมิอากาศต่างๆพวกนี้เราอยากจะรู้ว่าเขายังปลอดภัยอยู่หรือไม่นะฮะโดยคีย์เวิร์ดอันหนึ่งที่ดร. ฟรานเชสกาเนี่ยนำเสนอกับเราก็คือเรื่องของ digital twin digital twin ก็คือว่าการนำ BIM information modeling เนี่ยไป integrate กับการ operation and maintenance นั่นเองคือเราไม่จำเป็นที่ต้องเอาวิศวกรเนี่ยไปตรวจสะพานทุกๆวันเราเพียงแต่มี digital modeling เหล่านี้ที่จะต้องมีการมี information ของสภาพของสะพานซึ่งสภาพของสะพานเหล่านี้จำเป็นที่ต้องใช้เทคโนโลยีที่เรียกว่าเซ็นเซอร์ต่างๆที่เขานำเสนอเนี่ยก็เป็นเช่นการวัดการสั่นสะเทือนการวัดการยืดหดตัวของโครงสร้างการวัดอุณหภูมิต่างๆสิ่งเหล่านี้สามารถเราจะอินทิเกรตข้อมูลเข้ามาที่ตัว BIM Data ได้ทำให้เราสามารถที่จะสร้างเป็น Digital Twin ที่ใช้ในการบริหารจัดการบำรุงรักษาของสะพานได้แม้กระทั่งสะพานที่สร้างมาค่อนข้างนานแล้วยังไม่สามารถที่จะออกแบบตามโค้ดแผ่นดินไหวใหม่เขาสามารถที่จะเอาเซ็นเซอร์แล้วก็ Digital Twin นี้ไปบริหารจัดการให้เราได้สามารถที่จะประเมินและวินิจฉัยได้ว่าสะพานเหล่านี้ยังสามารถที่จะออกแบบรองรับโค้ดแผ่นดินไหวหรือไม่ถ้ารับไม่ได้ก็จำเป็นที่ต้องมีการบูรณะตัวสะพานนั่นเองนะฮะตรงนี้ก็เป็นเรียกว่าเป็นเทคโนโลยีที่มีความน่าสนใจมากถ้าเราสามารถอินทิเกรตเข้ากับโครงการภาครัฐต่างๆนะฮะเราสามารถที่จะบริหารจัดการเขาทั้งไลฟ์ไซเคิลได้เลยซึ่งเป็นสิ่งที่คงเป็นฟิวเจอร์สำหรับไทยแลนด์ในอนาคตอันใกล้นี้นะครับOkay, if you guys have some questions, I'm going to ask for you guys. You can ask in Thai. That's very interesting topics for you. Okay. Okay, maybe I'm the one to ask you. Okay. Basically, in Thailand, we also have some maybe semi structural health monitoring, like the first and the fifth. Thai-Laos friendship bridges. The question is, you know that when we have a lot of sensors to install in the bridges, and we measure the data every day, and you can see that sometimes we still need the experts to interpret the data. My question is, in the near future, do you have some plan to use the AI or deep learning method to help the engineer to make the decisions if the bridge is safe or not?
Well, this is a very interesting topic on the research field right now. Yes, the literature is exploring this possibility. One thing that needs to be said is that every structure is unique, either for the technology used to construct it or for its location. So the thing is, yes, we can create some AI algorithm to automate the analysis, but what we are seeing is that anyway, the eye of an expert civil engineer to look at the data and to being able to say if those analysis makes sense or if there is something else to be considered, I think it will be necessary considering the uniqueness of each and every structure.
Okay, very interesting answer. ก็โดยสรุปก็คือว่าจริงๆมันก็ challenge มากแล้วก็เป็นท็อปิกที่ยังใหม่อยู่คำถามผมก็คือว่าคือเนื่องจากการตรวจวัดโครงสร้างต่างๆโดยใช้เซ็นเซอร์เนี่ยหรือการใช้ Digital Twin เนี่ยสุดท้ายแล้วเนี่ยมันจะมี data ไหลกลับเข้ามาค่อนข้างเยอะมากเลยโดยเฉพาะถ้าเราวัดแบบต่อเนื่องนะสมมติโครงสร้างใช้50ปี70ปีเนี่ยข้อมูลทุกวันทุกวินาทีมันเยอะมากแล้วเราจะบริหารจัดการข้อมูลยังไงเพื่อให้ make decision โดยใช้ AI ได้ไหมซึ่งอันนี้แน่นอนว่าเขาตอบว่าเป็นเชิงเป็น research อยู่คืองานวิจัยซึ่งอาจต้องมีการขยายผลแล้วก็มีการพัฒนาเพื่อให้นำไปสู่จุดนั้นได้นะครับซึ่งก็เรียกว่าก็เป็นเทรนด์ของโลกเลยก็เป็นสิ่งที่เรียกว่า challenge ในประเทศไทยอย่างมากเลยนะฮะในการใช้เทคโนโลยีเหล่านี้นะครับ Okay, thank you so much. Anyone have some question for the experts? Okay, sure.
I'm wondering about the warning system, just in case something happened to the bridge, like the overload trucks comes to the bridge and the bridge defect exceed the limit. What kind of warning system do you have?
We have different kinds of warning system. We have preliminary warnings and actual alarms. So what we usually do is that we give the client the possibility to set the limits manually for the early warnings. For example, they know that the structure shouldn't exceed the reverse rotation. But then we validate these manual warnings by actual algorithm which were validated by the main Italian university and already present in the literature to analyze the actual variance of the data and everything connected to it, to give an actual alarm to the owner, which says that this is not only exceeding thresholds that they set it, but that there is something really off with the structure. And that is a serious warning that you can receive on your phone or by email or by call to be alerted immediately.
ครับก็เป็นคำถามที่เรียกว่าดีมากเลยนะคือทางที่ฟลอร์ท่านอาจารย์ก็ถามว่าปกติเราสามารถที่จะทำเป็น warning system กับโครงสร้างได้ไหมก็คือมีการเตือนข้อมูลบางอย่างในกรณีที่โครงสร้างเขาดูที่ไม่ปลอดภัยหรือไม่อย่างไรซึ่งทาง expert ทาง iCHE ก็บอกว่าสามารถดำเนินการได้โดยเขาต้องมีการ collaborate กับงานวิจัยต่างๆเพื่อให้ได้ค่าที่เรียกว่าเป็น threshold ก็คืออาจจะเป็น upper bound limit บางอย่างที่เมื่อตรวจวัดแล้วมีข้อมูลเหล่านี้เกินค่าลิมิตเหล่านี้นะฮะก็จะสามารถที่จะแจ้งเตือนมายังโอเนอร์ได้ซึ่งการแจ้งเตือนเนี่ยสามารถแจ้งเตือนผ่านทั้งอีเมลมือถือได้เลยซึ่งเรียกว่าเป็นไอเดียที่ดีมากเพราะว่าอย่างในประเทศไทยเราเองเนี่ยเราพอทราบอยู่แล้วว่าlimitation เราอันนึงก็คือเรื่องของworker ใช่ไหมฮะ engineer เราคงไม่สามารถเอา engineer ไปเฝ้าสะพานทั้งหมื่นกว่าสะพานในประเทศไทยได้การมีระบบ warning system แบบนี้ถ้าเวลามีค่า parameter บางอย่างเช่น vibration displacement ต่างๆมันเกินลิมิตปุ๊บเขาส่งมาที่มือถือของ engineer คนนั้นเราสามารถที่จะบริหารจัดการสถานการณ์ได้ทันซึ่งอันนี้ก็เป็นเทคโนโลยีที่ดีแล้วก็เป็นคำถามที่ดีจากท่านอาจารย์มากครับขอบคุณครับOkay, thank you so much. Very interesting technology, and I hope that in the future, Thailand is going to have some kind of this technology as well. Okay, thank you so much. Okay, we get into the last part of our session, and it's very interesting as well that we have Mr. Batra from Machiavelli, actually Italy as well, but I believe that he be the Southeast Asia managers from the companies. And the topic that he's going to deliver to our session is the sustainable infrastructures through BIM and digital construction. And this one going to be the last topic and going to be the topic that very important to link or digital construction to our goal in infrastructure in Thailand that we would like to have sustainable and resilient infrastructures. Please help me welcome Mr. Pratas for his speech.
Thank you very much. That's a nice picture of me. Guys, thank you very much. I'm sure everybody is tired by now, so trust me, I'll make it as quick as I can. Okay, so I'm Mayank Batra. I manage the business development for Southeast Asia Pacific region for Rockfall sector. How I'll start is I'll give you a brief about our company. We are almost 145 years old. Incepted in 1879, that's when we started making Gabion products. In 1893, the Gabions were first developed, and so on, the development kept going. And the rest is history. So far, we have sales in 100 plus countries. We have more than 3,000 employees, 25 plus factories, and 60 plus subsidiaries. And we provide solutions from coastal to rockfall, retaining wall structures, roads, pavements, design of structures, hydraulic works, and many more. You name a solution in civil engineering, Machiavelli has a solution for that. So today, we'll be discussing about smartification of rockfall barriers. We call the device HelloMac, Smart Engineering, Safer Communities. It has various applications starting from geo, hydro, environmental, infra, and snow. But today we'll be talking about geo. If you see on the screen, it's a dish-shaped device with 8 sensor legs going on 4 on left and 4 on right, like this. This is a very lightweight device. weighing around 8 kg. I'm sure you guys must be thinking 8 kg is not light, but okay, if you see the whole structure of a rockfall solution, this is considered pretty light. As we all know, when we install rockfall barriers or draperies, power supply is a big challenge there. So for our HelloMac device, power supply is not a concern because it is powered by lithium-ion batteries, which has a life of more than 5 years. Currently, we have 7 batteries in one HelloMac device. In past 7 years, we had case studies. We had HelloMac with only one power battery, and it's still working. So with 7 batteries, we are expecting at least 5 years. Okay, so how does this device works? We have sensors, they are triggered when an event happens, but how do you get to know? It works via 2 ways. First is satellite and second is GSM. So it's not like it will have satellite and GSM both, it will have any one of these. So there'll never be a point when the device will be out of coverage. And as we know that in terms of a rockfall event, time is of essence. Okay, so whenever an event happens, we have to stop the movement of people and traffic in that area. So when an event happens, the alert is received in less than 3 minutes. And how it is received is via SMS, a proprietary application, and email. So we have a proprietary application which is available free of cost for iOS and Android devices. And in this, we can also have the real-time insights of our device, where the device is installed, where the central system is installed in that. On the screen, you can see there's a Google map in the application. And in this application, it's not that one device can have only one application. Every device comes with its own user ID and password, and it can be used in n number of devices. So there's no limitation to how many devices can get the alerts. Okay, so let's make the community safe. In this, we have basically 4 applications, starting with smart rockfall barriers, smart drapery systems, retrofitting, and geostability monitoring. So let's begin with smart barrier system. Smart barrier is basically the rockfall barriers which have been installed on site, and on that we have installed the HelloMac. If you see, generally a rockfall barrier is of 10 meter span, left and right side both. Our HelloMac device is going to be installed on the top of the barrier. 4 legs on the left and 4 on the right will be covering. That means one device can cover 2 rockfall barriers, just like this. All those 4 legs, they'll be attached on the barrier. As soon as a rock impacts it, the legs will be triggered, the alert will be sent to the CPU, then on your phone in less than 3 minutes. That's it. That's the only job of this device. It's very simple. Now we have a case study in Palmy Beach in Italy, where the HelloMac was attached on the rockfall barrier of 300 kilojoules of capacity. This was done last year, and we installed 8 HelloMac on that barrier. Now we move to the next application, which is the smart drapery system. Okay, what is drapery? Drapery means when we have a slope with loose rocks, you have to save it. Save it using nets. And in the picture, you can see the red spider line things is the HelloMac which is installed on the drapery. Where's the pointer here? Yeah. Here you can see these legs going on. These are like spider web. These are the sensors. And in between, the HelloMac is attached on the rocks. So how this works is the principle says HelloMac and the sensor end has to be stable, so that when the movement happens, the rope needs to be pulled and the sensors are triggered. And moving ahead. Okay, so in McAfee, we have 4 types of solutions for slope protection: DT mesh, HEA panel, steel grids, and Mac armor. And our solution of HelloMac can be installed of all of these solutions. And again, the same picture, as I mentioned last time, it's going to be a spider-like arrangement. With one HelloMac, we can cover more than 1,000 square meters of area. And it's not that the only point where the HelloMac or the sensors are attached will be triggered. Any area in between, when any rock movement will happen, you will get a trigger and the alert will be sent on your phone. Another case study from Italy. We have installed 6 HelloMacs on a loose drapery system. The next, we are going with the retrofitting. Okay, what retrofitting means? For example, you have installed a rockfall barrier of some other company. As much as we want, all barriers should be of McAfee, but that does not happen. So if anybody's rockfall barrier is installed, our HelloMac can be customized and retrofitted on that. Rockfall barrier, drapery system of whichever manufacturer, our HelloMac can be customized. Generally, what customization means? This means setting up an energy levels to which a trigger happens. Okay, the question arises, what happens if some animals falls on the barrier? Will you get a trigger? No. The reason being, when we install it on a barrier, there are two energy levels in that. First is the maximum energy level, second is the SEL, service energy levels. So we always customize the legs of the HelloMac to those energy levels, so that when a rock hits, only that trigger happens. Otherwise, no false triggers. Moving ahead, another case study in Italy. This was on a debris flow barrier. This is a very important road connecting Italy to Switzerland. We managed to install 43 HelloMac devices on that this year. Going to the last application, which is geostability monitoring. What that means? For example, we have some loose rocks, but we have not decided yet, are they fatal or dangerous for us or not? In that case, when we are not in a position to do any production works for that, we can install HelloMac directly on the loose rocks, so that when any movement happen in those rocks, again the alerts will be triggered, and accordingly we can decide we need to put draperies or rockfall barriers over there. Here you can see a case study, again in Italy, for the railways where the HelloMac was installed on the loose rocks. 36 HelloMacs were installed. It happened 2 years ago. Okay, now enough about rocks. There are a lot of calamities which are not related to rocks. What can we do in that? And that's when we call it Make It Plus. What that means? That means we can, apart from the HelloMac, which tells you about the rock fall events, we can also attach groundwater level sensors, which we can also detect tiny cracks, slow moving masses, wind direction and intensity, rainfall and slope movements. And all these things can be integrated to one device. That means you will have only one application on which you will get the alerts. You need not to have multiple applications to get the alerts from all those devices. Every device will have unified application. Okay, so how does this magic happen? Sensors give a trigger. How will you get to know? So sensors have a gateway. We call it Hubir. And Hubir and sensor has to be installed at around 5 to 8 kilometers of range. These two devices communicate via radio waves, and from Hubir to data server, it goes via satellite or GSM. As we all know, in these cases, the movement of people has to be stopped. So what happens is, it takes 3 minutes to get the alert. It can be long, it can be fatal at that point in time. So with our Hubir, we can also attach local signals, sirens and traffic gates, which can stop the movement of people in less than 2 seconds, which has proved really well for us. We have managed to save a lot of calamities that could have been happened. This is another case study in Italy where a lot of debris flow events were happening because of heavy rainfall. So what we did was, we installed 2 rain gauges. You can see this is the one. Then in the valley we have installed the HelloMac. This is the one. Then at the bottom we installed Hubirs. When an application of this device is opened, you will always get this Google map. All those green dots will be defining HelloMac and the pink ones Hubir. And this is the graph that shows how the rainfall sensors work. Since we all know that every region is different, every region will encounter different intensity of rainfall, and every region will have a different level when it will be fatal for them. So in this one, we can always set the alerts: green alert, red alert, or amber alert. Whichever intensity is too dangerous for the region, it can be put in that, and accordingly sensors will come. And again, as I just mentioned, our Hubir can also be attached with automatic signals, panels, and gates in the cause of an event. And within less than 2 seconds, this will stop the traffic. And this is again the HelloMac device. We have this device present physically in the event. We have a booth here. I welcome everybody to please come and visit us. I'll give you a live demonstration how it works. It's a live working demo. And with this, thank you very much.
Okay, thank you. Very interesting information in your presentations. I'd like to summarize for the brief. So สำหรับตัว presentation สุดท้ายนะฮะก็เรียกว่าน่าสนใจไม่แพ้กันเลยนะฮะธีมของเรามาตั้งแต่การใช้ BIM Digital Construction เทคโนโลยีต่างๆมีการใช้ตัวเซ็นเซอร์ต่างๆในการ monitoring ตัวโครงสร้างพอมาถึงตัว presentation สุดท้ายเนี่ยเรียกว่าเขาก็ตอบโจทย์เราให้ถึงเรียกว่าทั้งองค์ประกอบของสะพานเลยนะครับเพราะว่าการออกแบบสะพานเราเองเนี่ยเราไม่ได้มีเฉพาะตัวสะพานเรามีบริเวณคอสะพานเรามีบริเวณถนนโดยเฉพาะอย่างยิ่งนะฮะถ้าท่านดูข่าวที่ในเมืองไทยตอนนี้เรามีเรื่องของแลนด์สไลด์มีเรื่องของสะพานขาดถนนขาดซึ่งที่เหล่านี้มาตอบโจทย์โดยทันท่วงทีเลยโดยเฉพาะคีย์เวิร์ดของเขาคือเซ็นเซอร์ของเขาสามารถที่จะเตือนหรือเป็นไซเรนหรือวอร์นิ่งให้กับไดรเวอร์ได้นะภายใน2วินาทีเท่านั้นเองดังนั้นถ้าเราดูดีไซน์สปีดต่างๆในทางหลวงเนี่ย80-90 กิโลเมตรต่อชั่วโมงเนี่ยการวอร์นิ่งภายใน2วินาทีเนี่ยถือว่าสำคัญมากๆนะทำให้เราสามารถที่จะเซฟชีวิตของประชาชนผู้ใช้ทางได้เลยนะฮะแล้วก็มีหลายๆอย่างที่เขาสามารถที่จะอินทิเกรตเข้ากับเทคโนโลยีของการมอนิเตอร์สะพานด้วยก็เรียกว่าเป็นเทคโนโลยีที่น่าสนใจเป็นอย่างยิ่งนะครับตรงนี้ก็เป็นตัวอย่างเทคโนโลยีในเซสชั่นสุดท้ายแล้วก็ท็อปิกสุดท้ายนะครับก็ถัดไปนะครับขออนุญาตสอบถามเนี่ยถ้าท่านมีคำถามที่อยากจะถามจากที่ฟลอร์ขึ้นมาเดี๋ยวผมขออนุญาตเป็นตัวแทนถามให้นะครับ Okay, probably we're going to have one last question for you. Okay, since I think in the room here it's very interesting to hear that you have basically the very quick warning system that going to sufficient to allow the driver to stop the car permanently. However, since your application of your device is in mountainous area, and I believe that it's going to have some battery or some kind of the electricity or power to supply the system. Is it possible to extend the external power source to be, for example, the solar cell or the wind energy so that we can last long manage that device for the whole life of the infrastructures?
Okay, thank you very much for the question. See, in this we have two components. First is the sensor, we call it HaloMac. That is powered by battery. So there is no need for power supply in that. And the second, which is the gateway system, it is called Hubir. It is powered by solar panels. It has a battery inside which once fully charged, which takes 2 days to full charge, it lasts for 30 days. If we install it in some area where we think that the solar panel is not available easily, the solar light is not available, in that case we provide it with the power supply. But the thing is, it does not have to be in the remote locations. HaloMac and Hubir can be in the range of 5 to 8 kilometers. So wherever we find a nearest, probably a electricity pole or an office, it can be installed there.
ก็คำถามที่ผมถามไปคือว่าเนื่องจากตัวอุปกรณ์เหล่านี้มันไปเน้นที่เรื่องของแลนด์สไลด์ต่างๆซึ่งอาจจะอยู่บนภูเขาที่มันค่อนข้างที่จะอยู่ค่อนข้างสูงกระจายตัวอะไรอย่างเงี้ยซึ่งแน่นอนปัญหาหลักๆของเซ็นเซอร์จริงๆในหลายประเทศคือว่ามันต้องมี power supply ไม่ว่าจะเป็นตัวแบตเตอรี่เองหรือตัวเป็น external source จากที่เราเดินสายไปต่อเนี่ยเราถามว่าเราสามารถที่จะ extend ไปเป็นเหมือนกับเป็น clean energy พวก solar cell อะไรได้ไหมนะซึ่งเขาก็ตอบมาว่าจริงๆเราสามารถที่จะอาจจะจัด configuration ของเซ็นเซอร์ให้มันไม่ต้องกระจายตัวกันมากได้นะเราสามารถที่จะใช้คนเนี่ยสามารถที่จะเปลี่ยนแบตเตอรี่ต่างๆได้ซึ่งก็เรียกว่าเป็นการมองขาดแล้วแหละว่าถ้าเราไปพึ่งตัว renewable energy ต่างๆเนี่ยมันอาจจะมีเรื่องของการชาร์จแบตเตอรี่ที่อาจจะใช้เวลานานแต่ถ้าเราใช้วิธีการกระจาย configuration ของแบตเตอรี่แล้วก็ใช้คนเนี่ยสามารถที่จะเปลี่ยนได้อย่างรวดเร็วได้เนี่ยก็จะสามารถตอบโจทย์ตรงข้อจำกัดตรงนี้ได้นะครับก็เรียกว่าเป็น practical sensor อันหนึ่งเลยนะที่น่าสนใจนะครับ Okay, anyone have some question? The last question? Okay, otherwise I'm going to wrap up the session. Okay, so basically our session is integrate all the industrials, the best practice partners from the software Midas that going to generate the BIM information or modeling that help the engineer to design and construction, and tentatively it can extend to operation and maintenance. And the last two topics for the session is we fill in the BIM modeling by creating the infrastructure monitoring data, not only the bridges, but also including all the mountainous or the landslides that is going to be the component of the highway structures. So by altogether integrating the BIM, the digital modeling with the smart sensors or technology that from our industry partners, I believe that we can create the smart and innovative infrastructures that help the governments at the US to provide reliable and safer infrastructure to the people. And this is the main key point of our session today. Please join me thankful to all the speakers for this today's session.